This is video number 2 for the sample exam number 4 for Math 107. In this case, you're given a certain amount of radioactive material and you're given its half-life. Okay, so here is the standard equation which you should know. The amount that you have is the amount you start with. So when you go to do a problem, write down the equation first. And it drops by half, 2 to the minus t over, I'll use h for half-life. Having written that, I will now put in the numbers. A equals, I started with 300, so the 300 goes here. Remember, it multiplies this. 2 to the minus t, and the half-life is 40. There's your expression. That's the equation. So you have to know this equation, and then you substitute in. And t will be in days. The next part says compute the remaining time at the end of 1, 2, 3, 4, 5 half-lives. Now if the half-life is, when you count by half-lives, then you see the pattern, and the pattern is it drops by a half for every half-life. The first half-life time would be 40 days, then it'd be 80, then it'd be 120, but you don't worry about the exact amount here, you just know that you moved by half-lives. Let me write a few of these terms out just so you can see it. So A would be 300 times 2, and let's go 1 half-life. So this would be 1, and I'll just put the h here as an abbreviation because right now I don't care what it is. Notice the h is a cancel, and this is 300 times 2 to the minus 1. 2 to the minus 1 is 1 over 2 times a half, which means you get the 150. Right. Now let's go to the next one. A is equal to 300 times 2 to the minus, I'm going 2 half-lives. So the 2 is here, 2 half-lives divided by h. See, the formula has the h here in the denominator. These cancel, and I end up with 300 times 2 to the minus 2. 2 to the minus 2 is 300 times 1 over 2 squared. 1 over 2 squared is a fourth. 300 divided by a fourth gives me the 75. The idea is every time you drop by half-life, you take a half of what you previously had. 300 divided by half, 150 divided by half, 75 divided by half, and you just keep going like that. This is a question on calculating the dB gain of the amplifier. You do not have to know the equation, it will be given to you. So the gain is 20, in this case, times the log of 2 voltages. The 0 is your output voltage, the I is your input voltage. So one big part of this, and the reason I give this problem, is to have you work a little bit with your exponents again. So I've got 20 times the log. Okay, the output is 5 kilovolts, and the input is 5 millivolts. So take them both down to the base unit of volts. 5 kilovolts is 5 times 10 to the third, because kilo is 10 to the third. Milli is 10 to the minus 3. So I've got 5 times 10 to the minus 3. And a lot of people struggle with this, but this is a very basic scientific calculation. We'll look again at it. If I just had 5x cubed over 5x to the minus 3, what would you do? Well, the 5's could cancel, right? Oh, put a different color here. But what about the x's? Same base, they're divided, subtract the exponents. So this becomes x to the 3 minus, well, maybe we just start this little bit again, and you know what, I'm going to start it again and use a different variable because, no, I'm going to do it again, just like this. Okay, so I have 5, and let's say it's x cubed over 5 times x to the minus 3. Okay, the 5's cancel, and I end up with x cubed over x to the minus 3. Same base, they're divided, subtract the exponents. So this is x cubed minus negative 3. Obviously those two negatives become positive, and this becomes x to the 6th. Now I want to make a comparison between the x here and this what looks like an x here. This x here is a variable. This x up here just means times. That's all. 5 times 1,000. 5 times 0.001. That's all that means. It's times. The reason you need the times is because if you wrote the 5 and the 10 next to each other, they look like 510. So you separate it by that x. That's not a variable name, right? And now let's do that problem right here. Remember what we just did. Now I have 5 times, and that's just an x cubed, divided by 5 times x to the minus 10 to the minus 3. I'm sorry. Okay. Again, the 5's cancel. Then what am I left with? 10 to the third over 10 to the minus 3. Even if they don't cancel, let's just, okay, that's fine, they do cancel. But you have the same base. In this case, in the previous example, the base was x. In this case, the base is 10. Same base, divided, subtract the exponents. So this becomes 10 to the 3 minus negative 3, or 10 to the 6th. So play around with that a little bit till you get an understanding of it. If you have problems with it, you can ask me about them. You can send me an email or give me a call or ask me in class. But I really like you to be able to do problems like this. Let me erase that and try another problem that's similar to that. See, I had 24 times 10 to the 9th divided by 6 times 10 cubed. Okay? In this case, again, these x's that appear here are times signs. They mean multiply. It's not a variable. So you have constants out in front which can be divided. I get a 4. And it's multiplying what? We have the same base divided, subtract the exponents. So this would be 10, 9 minus 3. So the answer here is 4 times 10 to the 6th. Do not write this out with a whole bunch of zeros and think you're going to divide it and not have an error. Use the exponential notation. When you get to be real engineers, you'll be able to divide millivolts by kiloamps and get all kinds of other numbers that you need in a set of units that you like. But here, we go back to the base unit and then handle the exponents correctly. Right, so now back to this particular problem. What I have here is 20 times the log. Remember, the 5's canceled, and it was 3 minus a negative 3 times 10 to the 6th. Okay, what happens with log? This 6 comes out in front as a multiplier. So I'd have 20 times 6 times the log of 10. Log of 10 is 1, so this becomes 120 dB gain on that amplifier. Here's another exponential setup problem. You have this weight loss program, says you're going to lose 2% of your weight every month. So start with something being your initial weight. Let's say W is going to be just your weight, and then your initial weight would be W0. So this is very similar to your radioactive decay or your bacterial growth. It's an exponential problem because you're losing a certain percentage of your weight every month. So for the first month, let's look at it this way. So you weighed, say W0 was your initial weight. I'll show you how this works out. At the end of the first month, your initial weight is multiplied by 0.98 because that is what you weigh after losing 2%. If you lost 4%, you would go W0 times 0.96, right? So it's whatever you have left over, and that's your new weight. Now the second week, should have been month, you have what you had at the first, right? And you only have 98% of that left. But what was W1? It was W0 times 0.98 times another 0.98. See, I substituted from up here. Then you get W0 times 0.98 squared, and you start seeing the pattern. And on the nth month, seem to have changed this from weeks to months. This should be month. On the nth month, you have your starting weight times 0.98 to the n, and that's how to set up the problem. You'll be given the numbers that you need for this next section. If you need to lose 25% of your weight, how long do you have to stay on the diet? All right, so here's what we do. Lost the pen here. Figure out what your goal is. If you need to lose 25% of your weight, you want to have 75% of your weight left. So your goal is 0.75 times W naught. This is another example where you don't need certain values because the base amount keeps canceling. So I have 0.75 times W naught equals, I didn't myself, maybe I've got enough room, W naught times 0.98 to the n, and we want to find n. So the reason you don't need to know the initial weight is because the W naughts cancel. If you divide both sides by W naught, then that's what you're left with. 0.75 equals 0.98 to the n. Alright, you can do this two ways. You can take log or ln. Again, you'll be given the numbers, but if you don't have the numbers, you can still work it out. The idea is you have to take the log of both sides. So here's log, here's log. Now what happens to the n? This n comes out in front as a multiplier. So you have 0.75 equals n times the log of 0.98. Isolate the n by dividing both sides by the log of 0.98. And the units here were wrong, and I better correct them on the other homework, in the sample exam. But I think you can figure this out. It's also rather fanciful.